Hello and welcome to this webinar titled Cut the Costs of Your FTTx Project, where we'll zoom into the FiberPlanIT Designer and show how it can turn your planning into profit. My name is Jonas Verstijft. I am a business development engineer for Comsof, focused on FiberPlanIT tool. I'll give you a short overview of the topics we will be handling in this webinar today. So I will start off with a short introduction to Comsof. Then we will focus on the network design challenges and how you can tackle those challenges with the FiberPlanIT Designer. And at the end, there will be some time for questions and answers. In total, I expect this webinar to take around 45 minutes. Like I said, there will be some time for questions at the end. I will answer some of the questions you can ask via the GoToWebinar Q&A window, which should be on the right side of your screen. So please feel free to ask your questions throughout the webinar, and I will try to treat them at the end of the session. After the webinar, you will be redirected to a website where there will be a short survey. If you could take the time to answer questions, it'd be much appreciated. And later this week, you can expect an email with a recording of this session. Now, a short introduction to Comsof. So Comsof is the company that develops the tool FiberPlanIT. Our head office is located in Ghent in Belgium, and we recently opened an office in Toronto, Canada to serve the American market. Our focus has been on FTTx network planning and design throughout the years, and mainly in software and in services as well. With Comsof, we have more than 15 years of experience in the telco space, and we've done projects in more than 40 countries. In total, this resulted in 120 projects throughout the world. And yeah, we plan more than 65 million homes with our software solution. So it's a proven solution across the world. Now let's zoom into some of the network design challenges that our customers and maybe you are facing as well, and how you can tackle those with the FiberPlanIT Designer. Now let's start with taking a look at the workflow of an FTTx project. So usually you start with strategic planning stage. So you plan your network, you run cost estimations, define your plan and timeline for your rollouts in the future. So for this we have the FiberPlanIT simulator, and I handled that topic in a webinar last week. So if you're interested in this webinar and in this topic, please reach out to me, and then I will provide you with a recording of that session. Then in this webinar we will handle the design stage. So when you have made the decisions to make to roll out the network, you need to design your network, and for this we have the FiberPlanIT Designer, and we will handle that topic in this webinar. Now for the later stages, the build, operate stage, we integrate with inventory solutions, so we won't be handling this in our webinars. But if you're interested in this, to hear about our current integrations or possible integrations, please also reach out to me. Now let's take a look at the network design challenges that our customers are facing, and that all operators or engineering firms might be facing. So the main goal is to get to constructible network design, so which can go into construction. But yeah, there are always network design guidelines to take into account. So there's a network architecture that you need to follow when designing the network, so that you get consistent networks every time. So the challenge for the planners is how to route all the cables, where to locate any connections, cabinets in that design, and where to place them in geographically. The last challenge is to get to the cheapest network. So you want a network design which complies with all of the architectures, which is constructible and which is also the cheapest way to do it, to be able to handle your budget. Now you can do your design manually and try to tackle all of those challenges. But what we see is that manual design is very time-consuming and repetitive. If you take a look at the graph, if you check how many homes a designer can do in a month, we estimate it's around 1,000 homes with manual planning. If you use GIS tools, which can have already some automation inside, you can maybe do 4,000 homes on average per engineer per month. Now, with fully automated and optimized planning, and I will go into more detail in the next slide, you can increase that number significantly, and on average plan around 25,000 homes per engineer per month. Now, the total, doing a design is a very complex job, and also go into more detail later. Doing that manually can result in errors, not following the design rules, or just some inconsistencies in the design. Definitely, if you have existing infrastructure to take into account, like poles or ducts, and you have the option to do new trenching, it can get quite complex. But the biggest challenge is with manual design is how do you know if it's the cheapest network possible that you're planning? Because every meter of trenching that you don't have to do can be a big gain for your total project. Now that's why we propose design optimization and automation. So to handle that complexity, handle the fact that it can be time consuming to do manual planning, we developed a tool called FiberPlanIT, which has optimization and automation built into the tool. But the biggest saving that you can get by using FiberPlanIT in your design process is construction cost savings. So because of the advanced routing and clustering, it will result in less cabling, less trenching, optimized cabinet placing, all of that. So this results in concrete construction cost savings. And then because of the automation, you will also have a time saving, so that time-consuming job of the manual planning can be handled by software. So the automation algorithms in the software apply the design rules of the customer. So it's consistent with the architecture and automatically creates all of the network elements that are needed to realize your network. Now, if we take a closer look to how FiberPlanIT does that and how the workflow is in FiberPlanIT, taking a look at the input data which is needed for the software. For that process to work, so we need two types of input data. One is the GIS data. So we use the locations of buildings, poles, trenches, existing underground routes as input data to the software, and we automatically pre-process that data. So we automatically generate where we could possibly run the network. So this is not something that user needs to do manually. Then the second part of the input data are the design rules. So you need to define the architecture which you want to use in your design and load in cost information, unit cost information on civil works, on all the equipment that needs to be used, so that the software can generate the bill of material and also determine the most cost-effective routes. Now, so these two types of input data get fed into the software, and then it results in a design and a bill of material, and I will go into more detail during the demonstration. One important fact that's also possible with the tool is fine-tuning capabilities. So this is quite important to get to constructible designs which are still cost optimized. So if there are restrictions to routing, like rights of way or any obstructions in the field, you need to be able to fine-tune your design to make it constructible. I'll show how this is done in the demo. Now let's take a look at the one simple use case, which is the FTTx network design. So the tasks are quite clear. When you do this, you need to deliver a network plan and generate the bill of material. This is also the same task for your manual planning. Some of the challenges that you can face in doing these tasks is you need to manage your budget. So that's what I indicated with, if it's the cheapest network possible that you're designing, how to make sure that you're not overrunning that budget. Then there's also huge time pressure. So you need to be able to deliver your designs on time so that you can build it and connect your customers and operate your network and have revenue coming in. There are design guidelines to follow, so it needs to be architecture conform. And maybe quite obvious, the design needs to be constructible. So when you hand over the plans to your construction team, they need to be able to build it like it is designed. So I'll use the FiberPlanIT Designer to show how we can tackle those challenges and execute the tasks that you're faced with doing your network design. We'll zoom into three main topics in the demo. So one is the FTTx design, so serving all of the homes in an area. I will zoom into the fine-tuning of your design, so how you can make changes in the software and why it's valuable to be able to do that already in the design stage and straight into the tool and not in later stages right before construction, for example. And I'll also show how you can do FTTC design, so reusing copper infrastructure and serving cabinets with the software. So it's not only used in fiber to the home design, but also in other scenarios. So let's take a look at the tool. So, like I said during the presentation, it can get quite complex if you need to do a design with manual planning. Here we have an example where we have some an area of around, I think, 800 buildings or so, 827. buildings that need to be served. So we have, the green dots indicate we have PON homes, so single dwelling units that need to be served with PON connection. We have some buildings that need to be served with point-to-point connection as well. So you will have different needs in your area. We also have some existing infrastructure we can reuse. So the blue lines indicate any existing pipes that are available. We have some existing manholes, existing cabinets, which can be reused at a cheaper cost. We also have some pole infrastructure, so they can save some costs instead of doing new trenching in this area. We have an existing central office, so this is our starting point. So yeah, it's really a mix of different input data that we have available, and the task is to come up with a constructible network design which reuses existing infrastructure as much as possible, which is clear. Now, if we take a look at how FiberPlanIT calculates this this network, we can see that it tries to reuse existing pole infrastructure wherever possible. We'll transition to underground routing where needed. And if we take a look, so we have existing infrastructure which can be reused, which lays right next to any possible new trenching which is available. But the software prefers to use those existing routes, so the blue line indicating a cable running into existing pipes instead of any roadside trenching which is used. And the way that it determines is based on the cost input data which is provided in the design rules, which I will take a look at in just a minute. But maybe first let's take a look at the details that the software comes up with. So if we take a look at the network design, so the way that the software outputs this network design is in 3 different layers. So we have the drop layer, distribution layer, and a feeder layer. And for each individual layer, the software indicates which cables to be used, where to place a drop point. So all of the cables and ducting that are needed to serve all of the homes in this area. This so fiber to the home design. Although the equipment is actually calculated by the software and outputted into this geographical plan. As you can see, it's quite detailed, and this is also represented in the bill of material. So after every calculation, this is automatically generated and gives you a breakdown per type of equipment or any civil works which are needed. Gives you the total volume which is needed for each type of work or equipment. So this is something that is generated after every calculation. So this is not something that needs to be set up manually. If we zoom into one particular layer, we see, for example, for the distribution layer, we need cabinets. This is the cost of the cabinet. This just provided in the input data, and see the number of cabinets which are needed in this network design. Also, you get a total overview of your costs. So a breakdown per layer of the network, which can be interesting to do some analysis. Now, all of the cost information which you saw in the bill of material and which is used for doing this routing together with description of the architecture. It's provided in the design rules of the software. So in here you can describe what your network needs to look like, which rules need to be followed, so corresponding with maybe paper design guidelines which are given to planners, which they need to follow. This is all loaded into the software, and it makes sure that all rules are followed, and that there are no that there are no faults in the network, so that everything is compliant with the provided architecture. And this is also a way to make sure that if you have different designers working on different areas, that all the designs are consistent and uniform. If you take a look at details which you can provide in the design rules, so if you take a look, so we specified in this particular example, you have a fiber to the home design, 132 splitters. So this is customizable, configurable, how to, where to place your splitters to make sure that you have that you get to your proper design plan. Maybe something important, like we saw in the input data, we had existing ducts, we had existing manholes, we have poles, we have standard trenching. So the software needs to know how much it costs to use every one of these particular routes. So this is needed because he needs to define the most optimal route, which is cost effective. So we input in the software what it costs to do standard trenching, so any new trenching which needs to be done, differentiating between street side trenching and crossings. And then we also can define how much it costs to reuse existing pipes and use existing poles and aerial connections, and based on all of these cost factors, the software will decide how to do the routing of the cables. And one thing that's important to know is that you can indicate per layer of the network. So for the drop distribution or feeder, you can indicate what type of routing can be used. So for example, if we take a look at the drop layer, here we specify that we can use aerial deployment wherever possible, so we can drop from a pole to a home, but we don't allow for existing pipes to be used. Also, this could be that you need to break open an existing duct too many times to drop to our homes, so this can be the reason to do that. Whilst for distribution layer, we allow aerial deployment, we allow existing poles, pipes to be reused. The same for our feeder layer. So it's really flexible to restrict or apply your sort of design guidelines in our model. Make sure that you get to your network architecture. Now, if we take a look at other parameters which can be provided into the tool, for example, in distribution layer, you can have a preferred distribution point location. So maybe you always want your distribution point to be on a pole inside a closure with a splitter, for example. Then you can make sure that it follows this rule. Also, basic configuration settings like the capacity of a distribution point or the cutoff distance, so what's the maximum distance that you want to reach from a distribution point. And also per layer, like with the restriction of reusing existing pipes or aerial deployment. You can specify the type of ducts and cables to use. You can have different cables available for each layer of the network. For example, here we have 2, 4, and 24 fiber cables in the distribution layer, but in the feeder layer we can use higher count cables, like 96 fiber cables. So yeah, the rules are set up so that they can be adjusted quite flexibly to your own network architecture, so that you can run a calculation and get to a constructible network design. Now, this was a quite small area of around 800 homes, but the software is also suitable to design larger areas. For example, here we have an area of 16,000, 17,000 homes, and software is capable of running the calculation in one go, giving you the total network plan, giving you the total bill of material as well, so that you can calculate the whole CO area, so the whole feeder area in one go. So this is, after everything is set up, the software automatically calculates this whole plan and design. You can imagine with manual planning can get quite complex and time consuming, while you can get an initial design with this in less than an hour. Now, this was more focused on the initial design, so initial fiber to the home design, coming up with your network plan, with your bill of material. The second thing I want to show is more focused on fine-tuning of the design. So we believe, and I think it's a common knowledge, that if you want to get to constructible design, you need to do field survey, verify where you want to do trenching, how you want to connect your homes, where you want to route your cables. So after this field survey, there can be some changes to your network plan, and instead of doing this in a separate software, or in a later stage or right before construction, doing very minor changes which can have a big impact on your cost, you can incorporate these changes right into your design process with the software. So I have one example here with two redlining indications. So here we say, okay, serve these homes from distribution point 40. So this is here distribution point 40, and we don't want to use this distribution point to serve these two homes, but we want to use this distribution point. Now you can easily adjust your network design based on that input, and include it into a different cluster. And by doing so, you impose a rule to your to the software. So it can be possible that you don't follow some rules from the software by doing that. So if you have specified in the network architecture and the design rules that you can have maximum 30 homes from one distribution point, can be possible by doing these changes that you exceed that threshold, and the software will also tell you. So you have verification over what you're doing with your design. So it's not a black box. You can actually see what's happening and react accordingly. Maybe allow some threshold to be exceeded or some rules to be broken. So this is one change we make, and after a calculation we will see how the network design is adjusted. Now a second change here is to place the distribution point further down the road. This is also something easily done with the software. So we had original distribution point here, and we can simply move the location and then recalculate to update all of the routing of the cables as this will need to change. Now let's open up the result of such a calculation, so of the recalculated design. So here we can see the blue cable indicating the feeder cable. So we moved our distribution point to a new location, and our blue feeder cable is now serving up to this point. So this is one change. The other change was located here. So we wanted these buildings to be served from a different distribution point. So we changed simply the clusters, so that was our action. And we see here we don't have any cabling or trenching anymore, but these these homes are served from another distribution point. When doing such an action, such a recalculation, it's always interesting to take a look at what's the impact on my costs. So if we look at the stage before we made the changes, this was our cost, and making the changes resulted in a bit higher cost, but not that significant. So 150 euros more by making those two minor changes. But you get immediate feedback on what it would cost to do the changes, so that you can make a decision based on real facts. Now, a third scenario was FTTC design. So with the previous workspaces and demonstrations, we focused more on fiber to the home. But also something that we can support with the software is fiber to the cabinet. And for this, our input data looks a bit different. So we have our demand points, our building locations. We have our existing cabinet locations, and the red lines indicate the existing copper infrastructure. So this shows how our buildings are connected back to our cabinet location. So this is used as input data to the software. Why is this needed? So we can use the software to determine where new cabinets need to be placed, maybe closer to the buildings. So reusing existing copper for the last couple of meters to the building, and placing new cabinets or new closures with active equipment to reach higher speeds for our customers. So this is one use case where we can use this feature. So we load in the copper infrastructure, load in the cabinets and the demand points, and then we can indicate in the software what the maximum attenuation would be, and any design rules related to that. So we can indicate what's the maximum attenuation we want to reach at our demand points. So this is associated with the maximum speed that we then can get over our existing copper infrastructure. You can indicate also how many fibers we want to reach to that distribution point. Maybe for later upgrades, we can also We can also take into account later upgrades to fiber to the home and provide additional fibers. Now, if you could look at how the software, what the software does based on this rule set. So let me clear this up. So we had our existing copper routes, which are the red routes here, and the software will determine based on the rules where new cabinets needs to be placed. So these are the red squares. So taking into account maximum attenuation and maximum size of such a cluster, it will determine where new cabinets need to be placed, and will show you how, to which cabinets these new these demand points are connected. So there will be a cut of the copper cable at these locations, and it will the buildings will be connected to active equipment in these locations. And then we also need to serve these locations with new fiber from our existing cabinet location or existing central office location. So determining where new fiber is running and determining where new cabinets need to be placed can all be done with the software. Like expected, the software will also give you the bill of material showing you most important impact on the cost is feeder cabling, so new feeder cabling that needs to be done to reach those cabinet locations. Now let's move back to presentation. So we zoomed on into a couple of different aspects of FTTx network design. Some of the challenges that we indicated was how to manage the budget. So with the software, you immediately get feedback on the costs with your bill of material, and optimization algorithms using the cost of new civil works and equipment that you specify in the architecture are taken into account to do cost-effective routing of your cables. So that's a way to manage your budget. It's an automated solution, so because there is time pressure with your network design stage, you can tackle that by using automation of the software. We zoomed into the design rules that you can specify, so that way you can make sure that your network design is every time conform the specified architecture and rules you need to follow. And then we also had a look at fine-tuning capabilities of the software. So taking into account field survey input can make sure that you get a constructible design in the end by fine-tuning your network design. So to conclude, by using FiberPlanIT Designer, you can lower your project cost. I think that's the main thing to remember. By using optimization, you get you will get to less cabling, less trenching compared to manual planning. Also, you can leverage the power of automation to get your designs out faster, to construct the network and to operate it and connect your customers. And a general point is also that the network quality will increase because of the fact that if you have multiple designs, and they will all be consistent, compliant to the specified network architecture. so it will be easier to operate your network in the future as well. So some final remarks. In the beginning of the presentation, I showed you a bit the complete FTTx project workflow. If you have more questions on the further stages, please feel free to reach out to us and can give some more information on our existing integrations, or we can discuss any new integrations with other solutions. So maybe final point on network design and also on strategic planning. So with FiberPlanIT, we offer this as a software solution, but we also offer services using FiberPlanIT ourselves for network design and strategic planning purposes. And please look out for an email later this week with a recording of today's session. Now, we still have a couple of minutes to get to some of your questions. Let me take a look. So first question, do you usually have all the info, ducts, poles in the GIS? So yeah, that's a question we often get. So the GIS data that you saw in the demonstration is data we got from OpenStreetMap or generated ourselves. We do need, if you're talking about greenfield solutions, this can be a starting point, but if you want to get to constructible designs, you will need to do some sort of field serving or use mobile mapping data to fine-tune your GIS data. Otherwise, there can be some inconsistencies when you go to construction. If you're talking about brownfield deployment, so using existing poles, using existing conduits, this is data that's provided by our customers usually. So normally they have this in their inventory systems. They know where existing poles are placed or where their existing ducts are running. If not, then there will be some some survey that needs to take place. Or for poles you can also use mobile mapping data. So there are different ways to get to this GIS data, and we can surely help you to do this. So if you have more questions on this, please reach out to us. Then I have two questions which are a bit related. Can you use any GIS, or is it only adapted for QGIS? The second question, whether the tool is built on QGIS as the map engine. So the software as a standalone product is using QGIS as a front end for calling FiberPlanIT and for visualizing and editing the data. It's an open source tool which we like very well. The data that is used in the software is shapefile information, so you can use you can load in the shapefiles and easily edit them with QGIS. The question whether we use any other GIS system, so we have some integrations at the moment with other inventory platforms which are built on top of other GIS systems, and it's always possible to use another platform. This is something that can be developed. One other question. Do you have provisioning for multi-dwelling buildings? So to handle multi-dwelling units in outside plant, there So this is something that is indicated in the input data. You need to indicate the number of inhabitants in the building, so the number of units. And then this can be taken into account for the outside plans. And there's also a possibility if you indicate amount of floors and so on to calculate the needed in-building equipment and provide this in the bill of material. For in-building designs, we work together with the inventory solutions and engineering platforms to do that detailed design. So this is our high-level design is done in the software, and then we can automatically generate the detailed design by our integrations and also do in-building planning. Another question. How do you know from the map information which properties are private, or you will have some troubles digging or placing fiber into it? Yeah, that's a good question. So this is basically something you could be able to indicate with the fine tuning of the software. So we saw in the design rules that you can indicate the cost of standard trenching, but there's also the possibility to indicate per street or possible route which subtype it has, and there you can indicate whether it's maybe private trenching or not, and then you can exclude this from the design. So if you have that information available, you can easily load it into the software, exclude it completely from the design, or give a higher cost to these routes. So maybe it's still possible to use these private routes or routes which are difficult to dig, but giving a higher cost, you can let the software decide whether to use it or not. And yeah, you can have an indication. You will have an indication of this in the bill of material and in your design output. Maybe one last question. I see there are a couple more, but maybe one to conclude. I will take up the other questions directly via email. One last question is: can you have different architecture for different neighborhoods? Yeah. So in the example that I provided, we had one single design rule for our area. Now it is possible that you have a mix of you have different sort of areas which you want to do in one design, and maybe apply different design rules to each area. This is also something possible to do in the software. So you can assign a set of design rules, so a set of costs and type of architecture to follow to a certain area. So you can indicate in the software the boundaries for each sort of design rules, and then come up with a mixed design. So it's possible that for certain areas there's a preference for underground compared to aerial. Just thinking out loud here. Or you have different sort of trenching costs for different areas. Then you can indicate that in design rules and then specify the boundary for those design rules, and then let the software handle that that design rule and indicate it in the bill of material. So this is it for today. So if you have any further questions, and yeah, there were some other questions which I will answer via email. If you have any further questions, please reach out to me, send me an email, or fill out our contact form online. Yeah, we'll send out the recording later this week, and after this webinar will be a short survey. Would be highly appreciated if you could answer this quickly. Fill the survey. Thank you for your attention and hope to see you soon.